Okay, everyone, let's welcome our first speaker, Colleen Farrelly, who is a senior data scientist at Datasembly, whose work has focused on natural language processing, topological data analysis, longitudinal data modeling, time series applications, and measurement models across many different industries. Outside of machine learning and mathematics, Colleen enjoys water sports and creative writings. In this presentation, she is going to give an overview of data science, detail her own journey into data science, and dive into some applications related to machine learning methods rooted in geometry and topology.
So I am Colleen Farrelly. I'm the senior data scientist at Datasembly, and I'm going to tell you a little bit about my journey into data science. It's one of the weirder ones out there, but hopefully you can get something out of this. My journey involved a lot of very interesting ways of getting into math, gambling, sports, my experiences with bullying, and finding the social sciences. So I was born into a small town to a family that traveled a lot for my dad's job. My dad actually did some work in Egypt when I was younger. My area didn't have a lot of educational opportunities, and there wasn't a lot of support for women or really anyone who wanted to go into STEM. There weren't mathematicians in my area, there weren't many scientists, and I didn't see people who looked like me going into these professions. However, my dad and I liked playing a lot of card games and dice games, and he would teach me about probability and how to calculate the chances of drawing 4 aces from a deck. And I really, really enjoyed math when I was little. However, when I got to school, I experienced a lot of bullying, especially gender-based bullying, especially when I was in middle school. There wasn't a lot of learning in my school, and we didn't have a lab for our STEM courses. There was a lot of resistance to having advanced opportunities in STEM. I remember when they wanted to skip me a grade in math, there were a lot of boys in my class that started bullying me a lot and lobbying to not have me have that opportunity. And these things really made me question like where I could fit into the world and within my faith community, like, did I even belong here? However, through my dad's job, I got to meet people outside of the little bubble that I was living in and see opportunities that existed elsewhere, people who looked like me, who liked the same things that I liked. And I ended up meeting a friend who really thought it was cool that I was interested in all of this STEM stuff and stood up for people like me who were getting targeted in school or who were being told that this wasn't an option for them. And he really encouraged me to get involved in some of these opportunities outside my school to be able to take some university classes early, start doing some research early. And I really started meeting people who are like me and encouraged me to keep doing some of this stuff. And I ended up spending a lot of my teenage years applying stats and pattern algorithms to sports data. That was what we were interested in, and it kind of blended those interests very well. When I got to college, I really struggled my first year. There were a lot of cultural things that I hadn't experienced before. There were a lot of assumptions about like what people knew about signing up for classes, what people knew about dorm life, and all of these things. But my German professor really supported me and helped me adjust to college. And I ended up looking into foreign language, social sciences, and eventually biology as research areas and areas of study. And mentorship really played a large role in the direction that I took there. While I was in undergrad, I taught and mentored inner city students who were interested in STEM. And I found a lot of people with the same background as me, not seeing people like them in professions that they were really interested in. And it really struck me just how hard it is to imagine yourself doing something if there's nobody there who's done it before. I ended up applying for an MD PhD program, which over here, you're getting a graduate degree in medicine and a graduate degree in something else through that program. And the school where I wound up had lots of topology and geometry workshops. I remember going to my first machine learning talk and falling in love with the subject. When I was growing up, I had a friend who just really loved sports, and I could see like just how much he loved doing that. And I'd always been looking for something that I could do all day, every day for the rest of my life. And I remember sitting in that talk, it was about random forests being applied to genomics data. And I just knew that that was what I wanted to do with my life. And I ended up switching degree programs partway through my MD PhD program to pursue machine learning full time. While I was in graduate school, I had a professor who talked about statisticians as gatekeepers. There are a lot of ways that data can be manipulated to tell whatever story people want to tell. And one of the key things in this profession is being a gatekeeper, finding the truth in data, and really making sure that noble ideas or enthusiasm don't result in bad products. When I finished graduate school, I ended up moving across the country for my first job. And a few weeks into my first job, I'm in a new place. It's my first experience working full time and my first experience being in industry. And there was a clinical trial going on, and the data was being manipulated. I found fraud. And it really hit me that this profession is a gatekeeper to quality. If there's a drug or a treatment program or a product that might hurt people or damage relationships with clients, we're the people who are going to see it in the data, and we're the people who can say something and make sure that bad products don't get into the marketplace. And that's something that's stuck with me throughout my career. I've been able to do a lot of really cool math-based things in my career. I was able to work on a network-based social contagion model to promote healthy behavior within populations. I've built another network product that was able to link genes, diseases, and information to help patients. I've worked on leveraging geometry and psychometric models to revise how law student admission, training, and bar preparation was done. In 2014, when I was finishing graduate school, one of my friends was working in Mali and was concerned about a potential Ebola outbreak there, which was going on in West Africa at the time. And I was able to use differential equations to understand what an outbreak might look like in different parts of the country, depending on how it got into the country, which was able to actually help them position resources to be able to help people when that did happen. One of my more recent projects is working on quantum machine learning. So looking at algorithms, particularly to solve a problem of nuclear reactor core loading optimization, being able to have safe nuclear power that doesn't cost as much. And my current focus at work has been on a lot of product matching algorithms to be able to match private labels to private labels. So finding out which products are identical based on their text. One of the career highlights that I've had that I didn't really set out to do, but just sort of happened, is building tech in new areas. So after my experience early in my career, when I had moved across the country, I ended up wanting to move back home. And I came back to Miami in 2016. There was very little tech in Miami. I actually had to look in a different county for a job. And I just kind of started connecting with other tech people in the area and supporting some of the events that wanted to come to South Florida. And in 2022, we have a pretty booming tech industry. We have a lot of startups here. We've had some of the major US tech companies starting offices down here, and a lot more tech in general. And that's something that I'm really passionate about doing, and I'm hoping and I'm pretty confident that at some point I will have the chance to kind of do this in different parts of Africa and help bring tech events and tech jobs to countries that really want a tech industry to start. So data science has a lot of different paths and a lot of different destinations. I've had one of the weirder ones, and I have a feeling that in the second part of my career, it's probably going to get even weirder. In essence, data science is about fixing what's broken and finding new problems to solve. There's a lot of different types of data scientists out there, but most of them have some of 4 core areas. They have some sort of domain expertise that could be in the social sciences, that could be in the transportation industry or consumer packaged goods industry. They have some software engineering skills. They have a way of looking at problems and solving them. And they tend to have a background in either machine learning and mathematics. Generally, early career people may only have 1 or 2 of these. And as you progress in your career, it's fairly common to get substantial expertise in all 4 areas. But most people kind of mix and match. So definitely, if you have 2 of these, data science is a great career to get started in. There are a lot of different routes into data science. So I've done a whole lot of these. One of the more straightforward ways is doing a quantitative master's or PhD. This is fairly typical to see in the field. However, we do have a lot of people with graduate degrees in a different field, plus a boot camp or internship, or maybe an undergrad in mathematics. There's also a fairly new path for those in bachelor's degrees to start as analysts and work their way up to data scientists through work and training programs that their work offers. There's also a new thing called a quantitative MBA. So people who want to go into business but are on the quantitative side can pursue that sort of a degree. But it's also possible to get into the field with some self-teaching and projects to start one's own business. I kind of started my journey in math as a self-taught person before I formally entered the program. And with the right background and the right resources, it's possible to enter that way. It can be really hard to break into the field, especially in areas that aren't real familiar with data science. So in my area, when data science was starting, there were a lot of questions about what is a data scientist? What should we look for in a data scientist? And that can make it hard to really get started in the field. However, I've seen a lot of things work for people in this field. One idea for breaking into the field is partnering with friends in other fields to get experience on projects and build a consulting firm. That's kind of what I did in grad school when I was helping the friend in Mali. You can also potentially start your own business with data that solves a problem in your area. So maybe you and your friends have access to a drone and can collect data on crop hardiness or flooding in certain regions or other problems that are facing your area. You might also want to look for government statistics and data science positions. Most governments are doing this these days, and that was actually my first position after graduate school. I was in a government contract that kind of hired out the analytics help. You might also want to consider research and teaching options, especially if your area doesn't have much in industry. It can be a great way to keep publishing and stay connected to the field while you're doing some stuff on the side. You might also have an opportunity to join a startup or a large company. Or perhaps you can start a totally new path and there can be another path into data science. It's a very open field. So some of you might be looking for remote or abroad options. I've looked into this a bit. The US, EU, and sometimes United Arab Emirates or Israel will offer these remote data science positions. A lot of them will let you stay in your home country while you're working. COVID seems to have opened this up more than what I had seen before. They're generally flexible. A lot of the times it'll be priced to whatever your country's typical data science salary is. Some will actually offer visa positions that will move you to another country. This isn't always offered, but it can be competitive. And for the adventurous folks out there, it can be a pretty good adventure. So some helpful hints if you're looking, especially for a first data science job, consider some of these multi-country early stage startups. There are some that will hire worldwide. It's usually good to apply on the company site rather than job boards or through recruiters. It's a little bit more personalized and more likely to see your application. It's okay to ask about salary range. One of the things you don't want to get into is getting really attached to a job that has a real mismatch from your salary expectations. A lot of places will either have you submit projects that you've done or take a coding test or do a project for them. Things are really in flux, and it seems like every year they change how they're doing recruiting in data science or how they're assessing skills in data science. So it's good to just kind of have projects on hand and stay up to speed on what's going on in industry. One of the things that I'm really passionate about is supporting STEM talent, especially female talent and minority talent. The visibility of women and people of color in the field is not great. I was looking at stats from the US, and at my level, it's about 12% women in data science. And that's really hard. And it's something that can really hinder people wanting to go into this field. It's discouraging when you can't find somebody like you. And I would suggest if you're in the field or starting in the field, volunteer, speak, enter leadership positions, stay in the field. I've seen a lot of women that I entered the field with who have left the profession. And there are a lot of reasons, but enough discouragement can really limit what somebody can do. Encouragement from allies is really important. So talking about that friend that I had growing up, that encouragement and protection really helped me see where my career and my life and my faith could go. And without that, I don't think I would have ended up in STEM. So if you're a dad or you're male and have female friends, if you're a teacher, if you're a boss, that encouragement can go a long way and can be the difference between somebody giving up and somebody continuing on the path when things get difficult. Life is going to get difficult at some point, and a career is going to get difficult at some point, and having that encouragement is really important. And another thing is, if you're seeing something, say something. Unfortunately, in this field, there is sexual harassment. There are biases. Everyone in the world, I think, probably has some sort of bias from how they grew up or what their internal feelings about things are. And sometimes this can come out in policies, or it can come out in how people are treated, and that needs to be addressed. So if you see something, say something about this. It's really important to have diversity and inclusion in tech. There's research out there that shows that companies that have more diverse leadership and more diversity on their product teams tend to make better products for consumers. They tend to have higher profit margins. And what's more, they're able to provide opportunities for the next generation to see people like them in the field. I found resources over the years and kind of put together this list. Women in Data Science is a good one. PyData has mentorship and conference opportunities. They particularly focus these days, I think, with South America, Africa, and Asia as areas for mentorship. Xindi is a great spot if you want to start doing data science projects and kind of get started in data science or build your portfolio. I really like Data Science Africa. They usually do conferences, which are a great opportunity to start speaking and presenting your work to have visibility in what you're doing. For the more mathy folks out there, Mfano Africa is a great resource. The mentorship will connect you with someone in your field. Khmer AI is another one that I've come across that does training workshops from time to time that are really good. And there's a group called Black in Tech that provides support as well as a job board for companies that particularly focus on diverse hiring. So let's move on to some topology and geometry in data science. I didn't realize just how massive this field is when I got started in topological data analysis. We have a bunch of tools from algebraic topology that exist in data science. We have homotopy, continuation, persistent homology, the mapper algorithm. We even have tools that are based on braids and knots in robotics and some of the sensor type applications. We have Euler characteristics and Euler calculus. Differential topology has given us a lot of tools based on Morse functions and the Conley index. Metric geometry is everywhere. One of the things that I've noticed a lot doing machine learning in practice is the importance of clean data, as well as a good distance metric. If you can clean up the data and you can find the right distance metric for your problem, you can see really huge gains in accuracy. Algebraic geometry is starting to play a role in data science more and more. Numerical algebraic geometry looks at some of these nonlinear algebra tools, which I think will probably start playing a bigger role in machine learning when the computational issues are solved a little bit. There are tools that are based on Hodge theory. In differential geometry, that's another huge area in data science. We have all sorts of curvature and flow measurements, so Ricci flow. We also have a lot of manifold learning, so being able to map from one space to another, which the whole field of deep learning basically involves these mappings between topological spaces. We also have a lot of kernel design. So Gaussian processes and support vector machines usually use some sort of a kernel. And there's all sorts of geometry principles that come into designing a good kernel. Lie algebra actually has found a home within image analytics of being able to kind of manipulate the images and create better training sets from small sets of images. There's a whole branch of discrete exterior calculus that's being used to render images and deal with engineering problems. There are tangent space models as well. My guess is there's going to be a lot more in this field, so anyone who's interested in this is probably going to find a niche. So I'm going to go through a couple of case studies. The first is with distance metrics. I've done a few projects on the side that look at claim payouts for insurance claims with mostly numerical data. I found that k-nearest neighbors regression tends to be a really good model for these sorts of problems. There's a lot of local factors that you can model with k-nearest neighbors. However, this is highly dependent on the distance metric. And I've found that having something that's more scale invariant and can handle outliers is good. So on the bottom, we have a Lamborghini, which is fairly common in Miami. We have some of these really high-end cars that are definitely outliers on insurance claims. If you damage this one, it's going to be a lot of money to fix it. And using a proper metric like the Mahalanobis distance can help wrangle that problem and not throw off your regression model. When I was in graduate school, I did a lot of work with adolescent development, and I found a use for persistent homology within survey design. So starting out in the social sciences, a lot of surveys are conducted that have some sort of hierarchy to their measurements. So we know that a lot of questions are going to be related to some overarching concept. However, looking at identity across contexts with different types of identity and different types of contexts, we don't actually have that hierarchical structure, and that means that we can't use factor analysis. However, this is a situation where we could use persistent homology on our subsamples to derive which scales might exist. Being able to do the clustering with persistent homology let us create these subscales and validate them across subsamples using a Wasserstein-based non-parametric test. And we were able to look at this across contexts to do some differential item functioning work across the populations that we surveyed in a multi-country study. So one of my favorite recent projects has been looking at Foreman-Ricci curvature. So in 2018, there was an Ebola outbreak in the DRC that looked like it was spreading through regional travel networks. I ended up doing some modeling for a nonprofit that was hoping to do some response within that outbreak. And the main objective was to find which regions were going to be hit next so that medical resources could be flown in and positioned to those areas. I ended up applying Foreman-Ricci curvature to look at the curvature flow within the travel network and calculate differences in this curvature over time to see how the epidemic was flowing. And I was able to identify the regions that were about to get hit. Unfortunately, in that situation, there were a lot of issues getting resources to those positions in the initial part of the outbreak. One of the more recent things that I've been looking at is text data. So the last few years, I've really been wrangling a lot of text. And one of the problems that I faced at work was exploring a large collection of scraped product categories to classify products of interest. So typically each retailer has their own way of classifying products, and we wanted to see if we could figure out some of the overarching categories that might exist across these retailers. So we looked at BERT embeddings to wrangle our text data into a low dimensional context aware dense matrix, and then looked at some supervised learning to predict product classes. Unfortunately, the BERT embeddings don't scale very well. This is a pretty typical problem within geometry and topology applications. A lot of times they don't scale so well, and we ended up kind of going with an alternative approach. But the geometry was really helpful in understanding what was there and what might be possible going forward. I'm open to questions. I hope you enjoyed that.
I have a question. So I wanted to ask you, like, in your experience, what industries do apply logical data analysis? Because I personally don't think anyone is forced in that, like not even in research. And it's very interesting. Like I first heard about it from a workshop that we've seen at the Mexican one. So I'm curious, like, if there are any industries that apply topological data science more than the others, or at all.
I think I may have missed part of your question. Could you repeat that?
Yeah, I was asking you if, in your experience, if there are industries that do apply topological data analysis more than the others, or at all.
Yeah.
Because I think it's more in research, and in Egypt, it's not even that in research. Like there are not a lot of researchers in that field in Egypt, so I'm curious about that.
Yeah, I've seen it used a lot in the medical field. There's a company in the US that does a lot of medical analytics with topology. And it's been used in finance more and more. So finding things within financial networks, especially persistent homology, I've seen that used to try to predict market crashes and be able to find different segmentations of the market. Those are probably the main ones. We use geometry a lot at Datasembly. That's kind of one of the main things that our group does. I've found with images and text data, particularly, geometry is being used more and more, or at least techniques that are rooted in geometry and topology, like deep learning is pretty rooted in topology, and it tends to work pretty well for wrangling this less nice data into something that plays well with machine learning. It's more of a pipeline tool in a lot of places, I'd say, rather than the bread and butter. But it's being used in a lot of data processing pipelines these days.
Okay, it was a great talk, and it's very helpful. And I think I really was interested in getting that exposure, because as I said, that you can hardly find anyone working at these specific fields in Egypt. So it was for me very helpful, and also the stories. Your story has like many stories inside, so that was also I always get inspired hearing these. And very excited. So thank you very much. That was very great.
Thank you.
Hey.
Hello.
Yeah. Hi. Thank you for the talk.
You're welcome. Thank you for having me.
Yeah, I mean, it was really interesting, but also touching. I mean, what you've been through your childhood.
I have to believe that there's a reason for all of that. And I've met so many people who have been through things or who have had to really fight for an education or to get into the field. And if I can use those experiences to help people, then I'm glad that I went through them.
Yeah.